What's up, Algebra 1? Continuing to practice some power rules, things that we really need to understand for the future of this course, as well as the future of Algebra 2, and also the ACT, so real important stuff for your education here. Let's talk about the power rules again. So I'm going to do a few of these, I'm not going to do all of them, but I want you to do all the other ones that I don't do. Every problem in the whole package should be complete if you're going to earn 100 for the homework, okay? So here we go. If you are dividing, first of all, you need to just treat coefficients like division. 2 divided by -8 simplifies to -1/4. Okay. Now that negative can go with the 2, with the 4, with the 4, or just out front, which is what I chose to do to show that the overall value is negative. 2/8 is 1/4 as a negative since you had -8. The power subtract, 3 minus 4 is -1. That's trying to tell you that there's an extra 1 in the bottom. Okay, so if you put something like x to the -1 over 4, you're not really writing the answer correctly. You need to respect that it has to be written as positive exponents and that negatives represent how many times you're dividing. Let's look at the next one on your own. I want you to do that one independently. I also want you to do 23 independently because that's very similar to the ones that you're doing in class a lot. I want to see how much you understand of that. Well, let's pick up on 24. These are problems that I see with juniors that still do not do well with this. First of all, the main reason they miss it is because they don't apply 3 to the third correctly. 3 to the third is 3 times 3 times 3, which is 27. Similar to the very first one, 2/8 is 1/4. We need to stick to what those numbers calculate. These are only rules for exponents that I'm trying to teach you. We don't want to confuse that with other things you already understand, like 3 to the third power. Now, another thing that students mess up is they think that S and T are both to the 12th power. Technically, that's not true. S is to the first, and when I apply that, it's multiplication, so that gives me S to the third. Now, T is to the 12th power, and when I apply it, 12 times 3 is 36. So a few things they miss. They miss the 27 part. They also miss this S to the third part. They usually get T to the 36 correct, but those other two parts is where I see a lot of mistakes. So let's talk about 25 next. If I can move myself out of the way. I need to start with saying 4 to the third. 4 times 4 times 4 is 64. Same thing with the 5 in the bottom. If I said 5 to the third, 5 times 5 times 5, that is 125. So I've gone ahead and applied that power to both the 4 and the 5, and if that simplifies, I'll do it. I don't think those simplify though, so I think that is going to be a good start for our answer here. Let's apply those powers. Like I said, 2 is multiplied by 3, so that's m to the 6th. This is multiplication, 3 times 7, that's m to the 21st. And then there's a 1 on this m down here in the denominator. 3 times 1 makes m to the 3rd. Now, like I said, if 64 and 125 simplify, like 2/8 made 1/4 in the first problem, then I will simplify that. However, that's not going on here because 64 and 125 do not share any common factors. So 64 over 125 is a part of the answer. However, these m's right here, I can use that subtraction rule. 6 minus 3 is 3. So that tells me that there's actually 3 m's in the top, and then I still have the end of the 21, and there's your final answer there. So at the back, and again, I want you to do 22 and 23. You need to do those on your own, and we'll talk about them in class tomorrow. We did 1 through 6 in class, so if you missed that, you just need to make that up. But we're going to start right here at number 7. Remember, negative powers represent how many times you're dividing. So with number 7, this is really 4 over c to the third. So we're going to move that down into the denominator because it's negative. And that's the answer right there, 4c to the third. Number 9, it's like -6, and I'm dividing by q squared. Okay, so that variable that has a negative power, it's moving down. It doesn't affect the number in front of it though, because technically -6 and 4 are both to the first power. So I don't need to think about moving them. Now if it's already in the bottom, like in number 11, it can move up to the top. So I'm going to change that to 1 times x squared, which is really just x squared. You can just say that's the final answer, x squared. Okay, instead of having 1 times x squared, you can just put x squared. If the negative is already in the bottom, it can come up to the numerator and it becomes positive in that way. Number 8, you got to really think about what has a negative power on it. The only thing that has a negative power on it is r. So that's the value that's going to move to the denominator. That is 2p over r to the 5th. Number 18, same idea. Find what has a negative power. I know 18 is a negative value, but that doesn't mean it moves. That is not anything new to you guys. We've been dealing with negative numbers for a while. What's new is negative powers. So similarly, as I circled this one up here, these both had a negative power. So negative 18 and a squared, no change. But b to the 3rd is going to change. It's going to come down and become positive. Similar to number 11, 12, z to the negative 3. I tried to show this today in class. I'm not sure how many people were listening, so I'm going to try that one more time. If I was just thinking about this value, okay, this is like 5 over 1 over z to the 3rd. Okay, now in Algebra 2, and I think even in other classes, we talk about instead of dividing by a fraction, we multiply by the reciprocal. So if this right here is the same as z to the negative 3, it's kind of like a complex fraction. It's like a fraction within a fraction. So the way that we get around that is we don't divide by a fraction, we multiply that top value by the reciprocal. So if I was to reciprocate this, z to the 3rd comes to the top and 1 goes to the bottom of that fraction. But that's really the same thing as just saying, like I was saying a minute ago, the final answer for this is just 5z to the 3rd. So seeing that there's a negative in the denominator, I can change that and it can become a positive if you move it up to the numerator. So yeah, definitely got several problems for you to work on here. I'm going to do just a few more, and then I want you to try the other ones independently. Now remember, you can get a full credit on your homework if you attempt each problem independently. Okay? So I think I'm going to try 13 and 15 with you. So it looks like another situation that we just talked about. A is in the denominator already, and it has a negative power. So I can move it up. And there's a negative 2x in the numerator. I can move it up and have a to the positive 4, and that's the same thing. I can move it from the denominator to the numerator by making that power positive. Now these, they're both negative, so it's like they both swap places. B to the 1 and a to the 1, which really, I think the best answer would just be b over a. So I want you to try 17, 14, 16, 18, and then I want you to try these independently. Again, no pressure, just try them on your own. If you just try each one, then we have a conversation about what looks right and what doesn't look right. If you've never tried it, then you're simply just copying down stuff that we talk about in class, and that's not learning. So please try these independently, and we'll check your work tomorrow. Have a good night.